Previously on the tower, we went to a local brick manufacturer. He showed us how to make the exact size, shape and colour of bricks that we need for the tower. And we also struggled to recreate the complex shape of the 600-year-old Merlons.
As far as we can see, the only thing that's happened in the last couple of months is this extra piece of scaffold's been put up. The purpose of that is so that they can stitch together the cracks in the brickwork and do some pointing around the windows. But I haven't seen any contractors here. The architect's on site today. That's Andrew Boyce. Seriously good man. If it wasn't for him, this project wouldn't have gone ahead. So come and have a look. So can we talk about these bricks, because they're fantastic shapes, but you don't think they were moulded bricks?
No, I think what happens here is that they cast them as what they call a red rubber brick, which is probably going to be a solid brick, rectangular, and then they'll have worked these faces out as they've gone along, and I think you can see that because the face of these on these,
yeah, you can see lines on them.
It's made up of a series of flats. It's not not a perfect curve, and actually also you can see that the moulded section is at a very slight angle as it goes up, so it looks as though they've worked them and they've handed some to try and get the bond. The idea of a brick is not that it can absorb the water. A good brick will absorb water and will let it back out again when it dries. The bad bricks are the ones that absorb and are too hard to let, they haven't got the right pore structure. So these ones, the fact that we can see the workings of those 500 years on from when they were put in the wall, that's amazing.
So you wouldn't be able to take a modern common
Oh
brick?
God, no.
Because they are hard.
No, they are hard,
right.
yes. Even the ones that we've had made, because they're not a through colour. You see, these are a through red colour. Right. That's the difference between these and the ones that we're putting in on the Merlons.
One of the problems we've got are these cracks in the building. They're only on this elevation. There's a bit of a design weakness, but it's lasted 600 years. So what we have to do, we'll follow these cracks all the way up the building, because they open up and then they close. But what we have to do is join this side to that side, and we do that with a process known as stitching. We use steel tie rods. We'll go upstairs and we'll see Mark. He's going to show us how it's done. So Mark, we're at the top of the building now. This is where the crack, this is the crack here?
Yeah.
This is the crack here, and we think the crack starts there. So we're going to put this first tie rod in here.
Yeah, that joint there.
And then what do you do?
Well, you start resin it in first.
Yeah.
And then you put the rod in, but you've got to put the rod central with a crack.
Okay.
It's evenly spaced either side of the crack.
All right.
Um,
And that has the effect then of joining this side to that side.
Yeah.
Using this as like a tie rod. The deal is it has to join the two bricks together.
yeah. But then obviously once you press the bar...
Yeah, as long as when you push it in, it goes up.
But then once you've done that, then you just go over the top with resin anyway.
All right.
And then once that's gone off, then it gets pointed.
There's two components in there.
Yeah.
And it's squeezed up through this here. You can see the twisty curly, can't you? Helter-skelter type arrangement. And it mixes the two together. When it comes out the end, it's mixed.
Yeah.
So what we're doing here is bonding that piece of steel to the brickwork along its full length using the resin.
Yeah.
Okay, we come back now. It's about an hour. This resin is set. So now Mark is pointing it. And when that's done, you can never see the steel bars behind. You don't know it's all been stitched together. Seeing this roof now, the concrete beams done in? Look at this huge area we've got to work on. You can dance on here if you want. A cracking idea of putting this concrete beam was. I wonder whose idea that was. Look at this now, the concrete beam's finished. Remember these areas of weakness that we looked at? Here and there and there. Now this concrete beam goes right across the top of them, takes all the load of all the building, so we're not worried about these anymore. No load going on them, no chance of them collapsing. It's a really good job. I want to show you something. If you're an engineer or a trained person, you've got a real eye for detail. You may not be able to spot this, so I'm going to show you this. See the coursing of this brickwork? This is English bond brickwork. So we have a stretcher, a header, a stretcher, a header, stretcher, header, all the way up till we get to where they built the new Merlon. And look here, stretcher, 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 stretcher. They've lost the bond. That's a detail that really screams and shouts out to a professional person. This is a grade 1 building. It's not really good enough. But have a look, there's something worse inside. See this brickwork? Stretcher bond again. English bond, stretcher bond. It's not even bonded into the building, this. And this is the chimney flue. The chimney flue we did over there was joined into the Merlon, so you didn't actually know it was there. This one is offset back here. And the deal was we'd walk it across and come up the back there. It's quite the most horrible piece of work. Next time on the tower, we get the big toys out again as we start to build the roof, and we show the clever design features which allows us to make spectacular changes to the roof layout sometime in the future. This is a seriously exciting moment. I've been waiting for this for so long.